So not much to tell them actually. So let me share the screen and just want to pass on this message that yesterday's homework is also not done. I'm not sure if people are finding the problem in doing that or anything else. So any comment on that from anybody, students?
Lokesh, may I ask just one question to students? So
Yes.
how many of you are very busy with the quark matter thing? Is it because of that or something else? Could you please raise hands if you are very busy with the quark matter abstract submission and all other things? No. Then I do not understand why.
Some of them might be involved in quark matter, but even if you are involved, just send one line that, or you say that you will do it later, maybe. Otherwise, we don't know that what's happening. So it is always good to interact. So with that, I think I should start because we have, as Siddharth mentioned, we have some time constraint. So let me start. And today's lecture is also, we are doing like yesterday, just hands-on experience with little bit introduction about AMPT. So AMPT is a multi-phase transport model, and it gives a coherent description of dynamics of relativistic heavy ion collisions. So yesterday we did the model PYTHIA, which was dominantly used for PP collisions. Now today we are going to do another model which is for heavy ion collisions explicitly. So this is a transport model which has four main components. One is initial conditions. Then you have partonic interactions. After that, there is hadronization. And then finally, there are hadronic interactions. So these four components make this model. And these are the authors listed. Web page is also listed. And then the codes are also there. In this web page, you can find. So the latest version which is listed there is this one. And if you want to go through full detail, this is a good paper which you can go through, and it has many details about the model and its implementation also. So what is the structure of AMPT is I'm going to show you here. Basically, you can have PA and AA type of collisions. Collision energies from 5 to 5.5 TeV, 5 GeV to 5.5 TeV. And this represents the basic structure, which I also mentioned you in the previous slide. So you have some collision, then you put some initial conditions, then partonic interactions, then hadronization, hadronic interactions, and then finally you get the particles, and from there you can do your analysis, whatever you want to do. So what are the physics processes and models for these various components are also listed here. So initial conditions are given by Hijing model. Basically, it provides hard mini-jet partons and soft strings. Then you have parton interactions given by this model, Zhang's parton-cascade model. It gives you the interactions among the partons. The parton cross-section is also listed here. Then hadronization is given by either this Lund string fragmentation model or quark coalescence, depending upon whether you are using default AMPT or string melting AMPT. Then hadronic cascade is involved using this model, art model. It includes mesons, baryon, elastic and inelastic scatterings, all things. And as I mentioned, it contains two versions. One is default. Sorry, something happened. Okay, just coming back. So it has two versions depending upon how the partons or strings are handled. So let me tell you briefly about default model. So this represents the initial conditions which is provided by the hygiene. It has many jet partons and strings. Then you have the partonic interaction, which we discussed. This mini jet partons, this goes to this part, and the strings are directly going to the hadronization part. Here, the partons are connected back to their parent strings, and then hadronization is done using this lone string fragmentation model. This is the fragmentation function. Then you have hadron cascade, and then final spectra. The difference between default and string melting model is that in this particular thing, the excited strings are converted into partons and put into this parton interactions. And then finally, you apply a quark coalescence model in which quarks which are close in phase space, they are combined to form mesons or baryons. And then you have a similar thing, hadron cascade and the final spectra. So I think this introduction is understood to you.
Sir, I have a question.
Yes.
Sir, can PB collection be simulated using AMPT? I am Suman, sir. I am Suman, sir, from IIT Indore. Sir, can we simulate PP using AMPT?
No, it's not possible, I think.
Okay.
PP is not possible. You can have P gold and gold.
Okay.
Yeah, okay. I have not seen actually anyone doing PP collision for AMPT. Yeah.
Like sir, AMPT default, which you have shown in slide 4, the hadronization process is Lund string fragmentation. Isn't it the same hadronization process used in PYTHIA?
It can be, but you see, you have this hadron cascade after that, and then what happens is you have hadronic interactions, which is missing in that model, right?
Yes, sir. So AMPT is suitable for heavy and that means small system.
Yeah, heavy and type. You can also use it for PA type of collisions.
Okay. Thank you, sir.
Okay. So now
I had a small question.
Yes, please. Who is this?
This is Priyanshi. I said Tirupati. So I had a question that you showed the one formula for sigma, that is the parton cross section.
Yes.
So does this mean that regardless of it's a quark or a gluon, all will interact among themselves with the same cross section?
Actually, this is approximated formula. You have the you have actually I don't remember actually. There is also Mendel's term variable there. So what happens is you have this mini jet partons and strings, right? And these partons are basically you put into this parton interaction part, and then when this is done, you combine them to your parent strings. So what is your exact question?
So what I wanted to ask is, does this parton cascade essentially just takes parton, or is it any distinction between quarks and gluons per se?
I don't think so here, because I have to also check, but I don't think so. Okay. I will check it, and I will,
and does it
I will let you know.
Is there any hadron cross section as well, although it will be different altogether for all? Is there any parameter for that as well?
I will show you in the input file. There are some parameters. And hadron cross-section, you mean how the hadrons are interacting, right?
Yes.
So this will be coming to this part, right? In the later part.
Yeah, correct.
So yeah, so I will show you that input file where you will find various parameters. Okay. Is it okay? Okay. So then we should move to the installation part, and I think if I go to, I want you to do it simultaneously, like we did it yesterday for PYTHIA. So if you can just go through this thing, and I'm just pasting this link there in your chat window, and you can download the code. And again, we have to be interactive, because then we have less time, and we should be doing it fast. Okay. So please raise your hand when you have downloaded the source code. And yeah. So I see one hand, Suraj Prasad, Neel Kamal, Dushmanta. Okay. So many of you have done it, and then I will go to the next part. Just unzip it and expand it, and then you will have this directory where you will have various things like source code, where you Fortran routines, readme file, make file, exec, input.ampt file, and there is one directory also which will be used for output data. So if you have unzipped it and seen these parts, can you please raise your hand? Okay. So I see many hands. Just do one more thing, that to compile the code, just type make and enter. And the hands I see have done this thing, or is it from the previous step? So just inform me when the make is done. Few people have done, I think. Jyoti, Prabhupada, Suraj Prasad. Okay. And Priyanshi also, Rakesh. So I assume that you have finished up to make. So next part is to just execute the code, and you can use either this command or this command, /exec Can you do that and see if the code is run?
Sir, I have one question. I'm
Yes,
Ritu
yes.
from ID. Sir, recently they have like another version like V2, MPT V2, then something, and in which they have incorporated the straightness enhancement, and but that I'm not finding. So could you please suggest me how to, like they have a paper in PRC.
Maybe they have not released that code yet. So I was also looking for that. They have
Okay.
not, I think, released that code,
Okay, sir.
that
Thank you.
version. Because the latest version is this one, which I have shown you. And if you go to the README file, it tells you all details about the versions, what have changed there.
Yes, sir. Yeah, I was searching for the latest version, but I couldn't find. So I thought I should, if I can take
Yeah,
some.
I hope they will put it there. But this is the latest version which we have.
Yes, sir.
Okay.
Thank you, sir.
Hello, sir.
Hello.
Yeah, I got a message that the following floating point exceptions are signaling while making dot slash.
Can you paste it? Maybe this is not an error, just a message.
Yeah, I was doing in another computer, so I cannot paste it here. So that is some IEEE underflow flag.
Yeah, this is just a warning. I think you ignore it.
Okay.
If you go to the ANA directory, there is some ANA directory, right?
Yes.
Prabhupada?
Yes, there is. Yeah.
Do you see some files there?
Yes, some DAT files are generated.
Right. So that means the program is run. If you see, can you go to the ampt.dat file?
Okay.
So if you just go through that file, you will see that.
I'm also getting similar, I mean, comment after executing embed. Just to
This
maybe
is,
not system independent.
yeah, I think this usually comes, there is some warning there. I think I have also noticed it, but it does not affect the output.
Yes, sir. I see inside the ANA folder there are some DAT files. So yeah.
Yeah. And this ampt.dat file is the output file which people usually use. If you can open that file, you will see that there are some numbers there. And I will just explain you those. Is it okay?
Yeah, okay, sir.
Okay. So then let me, you have some output file, nohup.out in your main directory.
Yes.
So that also gives you some status of how the program ran, right? And if you see that at last it gives you some message that it started and it finished at what time and so on. So this also give you some information about what you did. Okay, so with that, I think I will go on next. So this is the, if you want to generate some events of your interest, you have to do that in this file. This is input.ampt file, which is in your main directory. If you see, there are many parameters here. you can see all these parameters listed. We are showing you some of the useful parameters. So for example, you have center of mass energy, frame, then what type of target and what type of projectile you use, its mass numbers and its atomic number, then number of events which you want to generate, then impact parameter, what you want to keep. Then this particular step, which is shown here, iSoft. This is basically select between default AMPT or string AMPT. So as mentioned, for default, you have to use 1 here. For string melting, you will use 4. Okay. Then this is hadronic-cascade time. This represents the time up to when the hadron interactions takes place. And then you have this parameters A and B, this in Lund function. Then you have some more flags shadowing. This is related to partonic cross-section and so on. Okay. So basically, in normal analysis, what you have to do is you have to use these many parameters. And if you want to do some specialized studies, you can also do this. And then finally, this is a flag for the reaction plane, orientation of the reaction plane, which is normally 0, but you can also have it. Okay, so then I'm going to tell you about the structure of AMPT.dat, which is, as you have seen in your output file, these are the parameters, right? So what are these? Is listed here. So first line of your output file, which is AMPT.dat, it has these parameters listed, and this represent, first one is event number, then test number, then number of particles in event, then impact parameter, then total number of participant nucleons in projectile, in target, then total number of participant nucleons in projectile due to elastic collisions, inelastic collisions, and the same for the target. And then you have the orientation of the reaction plane. The lines which follow below this line represents the particle information. First one represents the ID of the particle. Then you have 3 momentum, Px, Py, Pz. Then you have mass of that particle, space-time coordinates, x, y, z, and t. The units are mentioned here: momenta in GeV per c, mass in GeV per c square, space in Fermi, and time in Fermi by c.
Sir, in the previous slide,
Yeah.
what is test number?
So test number, the details are not given, but I think this is what they try to simulate the event, and this is usually 1.
Okay, so like if event number I change to 10, so
This will be again 1.
Okay.
Yeah.
I think, sir, this number is not anything we need, I mean, for analysis.
For analysis, you don't need this number, but let me tell you that yesterday we did PYTHIA, and
Yes.
in PYTHIA, output file, the format of output file, how we want to keep it, and what parameters we want to keep in that output file was up to us. But
Yes.
when you run AMPT model, this is the standard format of the output file.
Okay.
So you should know what are these parameters. Then only you can use this output file for your analysis. Okay.
Yes, sir.
So this is the standard format there.
So one more thing, sir. Orientation of reaction plane, that is a default value, or that will change?
This is a default value. So in model, this is you know it is 0, but you can change it to some random orientation and do some studies. Maybe it will be useful for flow type of studies.
So it is like user dependent. We
Yeah,
can tune
you
it.
can change it. You can
Okay.
change it. I think I will go back. So if you put 1 there,
Yes.
then it will be changed, right?
Yes. 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 Okay. Thanks.
Okay. Okay. So then I think we are now in a process to generate some events. So I am going to tell you to please change your input file. You change number of events to 50, gold-gold collisions 200 GeV, and impact parameter 0 to 5 Fermi. If you can change that and generate the events, and just as we did for PYTHIA, you read this output file and draw the following distributions like charge particles, Px, Y, Py, Px, Py, Pz, Pt, phi, eta, and multiplicity. So just now I would like to ask you to please try to do this exercise, and then we will see if you are getting some problem or not. Okay. Okay. So while you do that, I wait for your signal. If you have hand raised, I will assume that you have done it. Prabhupada and Girja Shankar.
My hand was raised previously.
Okay, yeah, I just want to mention that you raise your hand when you have generated events, and
Okay.
when
Yeah.
you plot this distribution, just you can show to other colleagues also, so that people also know that people are doing homework. Okay.
Hello, sir. Hello, sir. I'm audible.
So Priyanshi, I was just checking that equation, that expression. So it is true that gluons also take part in this process. You had this one question, right, Priyanshi? Is she there?
Hello, sir.
Yes.
Audible. Okay, sir. It's from my team.
Ravindra, can you speak loudly? I cannot hear you.
Okay, sir. Sorry, sir. So, can you hear me? Hello.
The voice is not clear.
I guess there is some probe.
You can just chat, write in chat window if it is not clear.
Excuse me, sir.
Yes, yes.
Sir, if you can just show the slide where the inner door output meaning of all the column is mentioned, then it would be easy to understand which is PXP.
Sure, sure. You want this one, right?
Yes, sir. Sir, after I for the what you have asked for gold, I got the inner.out file, but sir, I'm not sure which one is PXP, sir.
Okay, so if you see this first one is your ID,
Mhm.
then Px, then Py, then Pz,
Okay.
then mass.
Is it mass? Okay. Okay, sir.
Sir, is it okay?
Yes, please. Who is speaking?
It's sir, am
I cannot hear you, Ravinder. You can write in chat window also,
okay?
or try speaking now. Maybe it will be better.
Sir, actually, I have couple of questions. If you can hear me.
Yes, yes, please.
Okay, so my first question is following to the Suman's question. So you said that there is some process uh, due to that we can't generate PP collision from the MPT. So is it possible to bypass that process from the source code and we can generate PP collision?
You can do that. I mean, you said that you just want to PP collision, right?
Yeah.
But it is not, I think, suggested by authors. If I go back to that, let me not go back because people are looking at this slide.
Okay.
So let me check. I think you can just ignore the last step, which is the hadron cascade. It might be possible. So there is let me check it. Yeah, I think you can do that, but I have to find it how to then switch off this process, this art, because basically this was for heavy ion, so I did not pay attention to this part, but maybe it is possible.
Yes, sir. Other than this, like you said, if you choose one option, I guess slide 4 or 5, this is for default, and then if you choose 4, then it is string melting. So is there anything between them? I mean, 2, 3?
Can you repeat, Ravinder?
Yes, sir. Like you said, sorry, sir. Here default for the default we choose 1, and for string melting it is 4.
Right.
So between, I mean, 2 or 3 something. So is there some process connected?
They have tested these things. If you go to this README file, it will tell you that they have tested few things, but you should not. I mean, they do not encourage you to use it.
Okay.
If I go to their manual, let me see. So they say that they have tested it. So this is like that. Note that the values 2, 3, and 5 have never been used for publications. They are tests of other string melting scenarios, which they have listed some processes.
Okay.
So they are tests, but they have not encouraged you to use those things.
Okay, sir. I have one final question.
Yeah.
So as you showed that output file is written in the .dat file, and
Right.
how the output parameter are listed in that.
Yes.
So is there possible way to connect root libraries with it?
For AMPT, I don't think. Only thing you can do is by including root libraries, you mean that you want to have some histograms, right?
Yes.
Yeah. So for this, I think one thing one can do is read this output file,
Yes.
and from here you can fill the tree, which is not very long tree, which will not be very long macro. You just use this as you are reading right now. People are doing this exercise which I have given. You can use that macro and fill the tree. In tree, you need only those variables, and then you can use them further in your analysis. So this will reduce the size of your output file.
Yes. Thank you, sir. Thanks, sir.
Yeah. So I do not see Priyanshi because she had one question which I tried to reply, and she's not there. So maybe I will contact her offline. So anything, I mean, just want to mention that in the input.ampt and in the README file, all the explanations and things which you can do with this program are listed. So according to your need, you can try to do that. So Somen and Ravindra has that question that if we can use this for PP and how to use it for PP. So basic idea is, if you see the input file and there is this parameter called hadron cascade. time. So I think you can reduce this time to just make it similar to PP collisions, right? Yes, Somen and Ravindra?
Yes, sir. Hadron cascade time, if we reduce
Yes, sir.
that.
Yeah, so there is this anti-max. This you can reduce, and then you can use it for this
PP system.
yeah.
Okay, sir. Thank you.
Thanks.
Yeah, there are many things which I mean, if you try to go through this, you will understand more, just because we are concentrated on few parts, so it is not covered fully. But yeah, I will suggest you to go through this input.ampt and readme file thoroughly if you really interested. Okay, anyone ready with the plots? Because we are almost towards the end. And will you send me the output if you later on, if you are not able to do this? So any progress? People can tell me at what stage they are, so that
I have generated the events.
so there is a question that how we can generate large number of events in parallel files. This was from Anju. Anju, can you make it clear to me? I do not understand your question. Anju Sharma. Anju, can you hear me? So it seems that people are not in front of computer or what? So I see message from Hirak that he has generated events and he is writing code. Anybody else writing code now? Suraj Prasad. Okay. I think I will stop here because as you know, there is a time constraint. We have to also finish the agenda. If you find any problem in doing this, I'm repeatedly asking you, if you find any problem in doing this, just contact me. I will try to help you. And even if you send me the output tomorrow or day after tomorrow, that will be also fine, because then we understand that you have learned something. With that, I think I will stop. Siddharth, are you there? I think I can stop and.
Yes, Lokesh, I am here, but I do not see Professor Mohanty joining yet.
So till
So
he
maybe
is there, we can continue this session, right?
yeah, you can continue unless
Just
he's-
inform us when he is here, so we can stop at that time.
I will just let you know.
And people, if you have any question, you can ask. You can ask me also after the class, and I will try to answer.
Hello, sir.
Yes.
Sir, I have a basic question. One, just that my question is that when I am reading a paper that regarding the Monte Carlo predictions of the impact parameter, that in some specific collisions, let's say suppose lead collision, I saw that the impact parameter changes with the center of mass energy collision. And my question is why this is changing with the center of mass energy?
Why impact parameter is changing with center of mass energy?
Yes, sir. For same centrality classes.
I actually do not get your question. Can you try to explain or share something which might be helpful?
Okay,
You are
sir,
talking about AMPT, right? First of all?
Yes, sir. Yes, sir.
AMPT.
AMPT, and there is an input that we have to input an impact parameter.
Right.
For some centrality. So if we are trying to generate a lead collision at 5.02 TeV, we have some impact parameter. Let's say suppose for 5 to 10% centrality classes, we have specifically 3.5 to 4.9 in Fermi in
No.
range.
The question is, how do you know that it is that centrality? That is my question.
Actually, I have a paper regarding Monte Carlo predictions of the impact parameter. And this paper, hello sir.
Yes.
And this paper shows that with the other energy, let's say suppose lead at 5.5 TeV energy, the impact parameter changes a little bit. Not so much, but a few amount.
Okay.
Sir, I can mail you the question and the paper actually.
Yeah.
If we...
Just to give you a little idea here.
Okay, sir.
Yeah, you can send me details also.
Okay, sir.
So when you do this AMPT, you just input B min and B max, right?
Yes, sir.
And from here, you can have a distribution of your impact parameter.
Yes.
Right. And also you have the number of participants as an output. Right. So
Yes,
you
sir.
can have the distribution of number of participants.
Yes, sir.
Or you can, in your data, what you can do is you can select the charge particle multiplicity within some pseudo rapidity.
Yes.
And then you can use that distribution to get the centralities.
Okay,
Right?
sir. I understand, but actually my question is not like that. Actually,
So you are saying some observation that with centrality, the impact parameter ranges get changed. This is what, if I understand correctly?
Actually, if I can share, maybe.
So then I have to stop sharing it. Maybe.
Lokesh, just to inform you that Professor Mohanty has joined, huh? So whenever you find it suitable.
Yeah, I think it was just some extra discussion. Maybe we should continue with the next class. So Hirak, can you send me details? We can talk offline
Yes,
also.
yes, sir. I can mail you, sir. I can mail you.
Right? Okay. Thanks. So please send me the outputs, and then we can further discuss if you have some questions. Thank you.
Thank you, sir.
That I'm done, I think.
Okay. Thanks a lot, Lokesh. So